Hi everybody, I'm Fahim and I'm gonna show you how to get a good rotation for your ball in no time. Since everybody have an assignment or on heavy versus light ball, I thought it would be useful to quickly get a good result and a good physicality. So sorry for my bad English, I will try to do my best to make it clear. Okay, so like you see, this is the final result. My little video work for any bouncing ball. As long as it is on one axis, you will get a result like this with a strong physicality with no problem. Okay, so let's get started. Okay, so I delete my ball here and I hit create polygon sphere and it starts here. Notice that my radius is set on 1, means that from here to here, from the center of the sphere to here, I have 1 unit. Okay, it will be important for the next part. Okay, so I put my ball on the 0 point of my R and modify freeze transformation. In fact, here my ball starts from 0 and all my values are set to 0. I name my sphere, always do that. Okay, so my sphere is here, it's my ball and it starts here. Okay, so I want from this point. Okay, little tip: if my ball has a curve, a S curve, or say a curve, it won't work. It won't work because if more than one axis on rotation is involved, it won't work. Notice that it will work only on one axis, this axis or this axis or even this axis, and one rotation. Okay, so go back to the side view, everything set to 0. Okay, I said everything set to 0. Okay, so I want this ball to go from here to hit the wall and slightly go back. So I'm here, I hit S, and all my units are keyed. Like you see, I have my key. Everything is in red. Important note: I didn't any thumbnail, video reference and stuff. It's for the purpose only of showing you how it rotates, how to get physicality with rotation. You have to make your video reference and stuff. It's just to help you do that. Okay, so don't send me some message and tell me, oh, there's no video reference and stuff. I know, it's just to show you. Okay, so at frame 80 I want it to hit here. Okay, so from this point it hit this point, and at frame 100 it goes back from 1 unit. The units are not important. You can make any unit you want. I just choose some square numbers to be sure that it's understandable. Okay, you can make 15, 18, 60.80, 39. There will be no problem. Okay, it's just to show you. So I have my little animation pick book. There are some ease in and ease out we don't want, so we're gonna go back to the spaghetti land, and in the graph editor I have my curve like this. I want my ball to give the feeling of it's already rolling from another point, and when it hits the wall, it it hits hardly the wall. So I gotta create a small bump as it hits the wall. Oh no, don't want that. And sorry. And after it hits the wall, it tends to slightly decrease. Okay, so don't mention the curve, the shape of my curve. It's only for the purpose of showing you a good result. Like you see, pock, pock. Okay, the one thing left is our famous rotation. Okay, so from this point to this point, we want this to rotate. So from this point, say 0 to 18 to frame 80, it has made 28 of the distance units of Maya. 28. Okay, so we have a small calculation. Don't be afraid. Whoa, what's this? No, it's really simple. So our distance 28 divided into 2 multiplied by the number p multiplied by the radius of our sphere 1, all of that multiplied by 3060, which gave us the number of rotation in degrees. Okay, the value of rotation in degrees. Okay, so if I interpret what I said, my distance is 28, and 2 multiplied by p multiplied by 1, which is the radius of my sphere, gives us 6.28. And I take my calculator and I do. I said the distance 28 divide into 6.28 gives us 4.45. So 4.45 multiplied by 360. 4.25 multiplied by 360, which gave us 1602. Sorry for numbers, I really suck at numbers. Okay, so at this point we have 1602. Poof. See, now I have a rotation, but it's still sliding. No problem. I will make the other part. The other part is, like I said, from 80 to 100, I go back on 1 unit. I started at 28, I finish at 27, so I make one distance. So I take it, my distance is now 1, the radius of my sphere is the same, so I keep this and I make 1 divided into 6.28 gives us 0.15. So 0.15 multiplied by 360 multiplied by 360 multiplied by 360 gives us 57.32. Sorry. I will minus that with the actual value of my sphere. So 1602 minus 57.32. Shtuk will give us 1544. At this point I have 1544. Look, and when I hit play now, sorry, when I hit play, pop. Okay, for the sliding stuff, go to the spaghetti lamp. Okay, spaghetti lamp, and the only thing is to make your Z rotation match with your distance, so the Z translation. It could be the X translation, the Y translation, depending on where you did your translation. So for us it's Z translation matching with this curve. So I take my curve, rotate X, tack, put it on spline, bing, I put it both of them, and Shtuk, I start with this tangent, Shtuk, take this one. Oh, that's because, ouch, I'm gonna put it there, I'm gonna Shtuk, break the tangent. Oh, hate when it does that. Somebody knows why it does that? I really wanna know. Okay, Shtuk and Shtuk. Why I match that? Because the idea is when it slides is to get no sliding. Sorry, Shtuk. The more you match your curve, the better your physicality will be for the rotation. Okay, so it's not quite perfect, but it's good, and everything is done. Like you see, up a little play blast, poke, and it's done. Pack. If you're planning and your timing, your spacing is good, your rotation will follow the translation. So keep focus on the translation, and your rotation will be good, and you get a great physicality. If I wasn't clear enough, or you want more information on the rotation, don't hesitate to send me a private message at my address here, or search my name on Animation Mentor, and you will find me, and I will answer your question. Hope it helps, and see you around, and good luck with your assignment.